All right, check one, check two. I think we're live and going. So let's dive into this. Hello, welcome. I am Alexander Booth. I am the new head facilitator instructor for the IBM Data Analytics Bootcamp April 2026. And technically, this is our week 6 live session. So I'm jumping in right in the middle of the bootcamp here. I understand that your last instructor had some medical emergency and had to recuse himself from the rest of the cohorts. But really wanted to kind of walk us through basically how I'm going to be supporting us over the next 5 weeks, or 5 to 6 weeks, depending how long this lasts. You may have seen me poking around the forums already over the last week or so. So I think I'll be in for about 6 weeks. But yeah, it should be a fun time together here. I know no one can make the call today, but I'll still ramble for about an hour or so, and we'll see what we can do. But yeah, big ideas here. Notice we're in week 6, so we're on SQL databases, how to write queries, all that good stuff, and how SQL can be used for both data analytics and data science specifically. Let's review where you've come from, where you're going. So you started with kind of week 1, foundations of data analytics, and then week 2, which is your crash course of Excel, kind of a fun week. And then week 3, creating data visualizations in Excel, and I think IBM's like visualization business intelligence tool. So I'm going to be picking up around week 4. I may go back and add in lectures for these other ones, but I think the last instructor may haven't done those from my understanding at least. So yeah, we'll be starting with I'll say week 6, but I'm going to go back and record lectures for weeks 4 and week 5. So just kind of where we're going after we kind of finished up visualizing data, we moved into learning our programming language for the boot camp, which is going to be Python. So week 4 is all about thinking like a computer scientist, thinking about Python, what it means to write a computer program, understanding your variables, data structures, conditionals, iterations, etc. And then we end week 4 by going out into the world, getting a real data set and pulling it back into our environment using Python. Week 5 is all about specs, our data cleaning, right? Fleshing out our ETL, extract, transform, load data pipelines. Now that we are comfortable writing programs for automation and using programming to go out in the real world and get a data set, how do we clean it up using Python, right? How do we create functional data frames from APIs, from HTML, all of that good stuff. So focusing on data extraction and data transformation. That takes us to week 6, which is now that we have this data set, what do we do with it? How do we write it back to a single source of truth as a database? And also, how do we query data out of a database to use for downstream analytics? Where we're going for the next couple weeks. Next week, we're going to be actually analyzing data. Week 7 is our big exploratory data analysis week. We will be data wrangling, taking data, getting it ready for modeling, ready for analytics, ready for statistics. Then we're going to be creating visualizations, creating aggregations, creating leaderboards, and then running them through simple regression models. And then finally, in week 8, we're going to be doing a deep dive into data visualization, culminating in creating interactive data apps using Dash and Plotly. And then it's the capstone, and then we're done. So just to make sure we all understand our live session schedule, just in case anybody else wants to join me in these live sessions for the rest of the boot camp. If you go to more here, you should be able to go to calendar, maybe, maybe not. I think it's more so at the, I thought it was somewhere at the homepage you could do that. But I think I'm on my instructor view. So we'll get on the bottom. I'll look at all my live sessions. So for the calendar here, we're going to be today only. We're at 1:30 p.m. Eastern or Central Time, 2:30 p.m. Eastern, which I know is a bit late for some of you. So I totally get it. But starting next week, we're going to be on Tuesdays at your normal 1 p.m. Eastern time. Know that I have to do Tuesdays as I had a prior conflict on Mondays at 1 p.m. Eastern. So our last 4 live sessions will be on Tuesdays. And notice that I'm going to be launching Module 7 on Wednesday this week. I know you probably already have access to it, but the way that the modules were released, we're like a week off as well. So we're going to be doing Module 7 next Tuesday. then module 8, 9, and 10. So we're going to be done around June 16th. This also means that for our capstone submissions, you'll be submitting your capstones the week of June 16th. So I think they're supposed to be due around the 17th, but I'll give you the whole week to turn them in so I can turn around and grade them. So capstone projects will be due the week of the 16th. So keep that in your mind as well. All right, so let's see. I'm also pretty active in the forums. You'll have seen me. I've gone all the way back to module 4 to start posting stuff in the forums there. For module 6, we'll take a look at the forums here. No one is talking to me, but it is what it is. Hopefully, you all see these videos and start reacting. So you're going to see that I've added a couple special forums for each week. There'll be a general discussion. This will be where I'll post the recordings as well as random like sneak previews. And if I do any recaps or recap videos, I'll post those here as well. So you see I've got some interesting stuff around SQL, just my own big ideas, my own thoughts that I've posted here as well. And then finally, I added another one for the live session. If you have any questions you want me to answer, whether asynchronously or live during our live session, then feel free to drop anything there. I may also drop some notes into there too as I'm talking during the live sessions. So, pretty interesting stuff. Let's see, what else, what else, what else? I have a GitHub repository where I run and back up all the notebooks of the week. So if you go, I think I've linked it here. Yeah, here we go. So if you go into my GitHub, you'll see that we're in the IBDA April 2026 class, and I've actually backed up everything from the first 6 weeks. Notice there wasn't really any notebooks or content in the first couple weeks, so I just have the downloads. But yeah, starting in week 4, I should have all the notebooks and things. And then when I get to recording live sessions for week 4 and week 5, I will add those notebooks to the live session folders. And anything that I do live today in the live session, I'll add to the week 6 live session folder. Also in my GitHub, you'll see my slides. That's what the presentation is. If you're curious, this is like all my slides are for the week 6. There's really nothing here. But the more important one is I have lecture notes that I put together before each live session. So I call that like my big ideas folder. You can open that up and read it. It's got all my big ideas for a lecture today. And then my README, of course, also has a good overview for the analytics bootcamp. So there's a lot of content, a lot of materials that I put together for your success. So definitely try and use them or maximize your usage of them if you can. Let's see, maybe we'll just jump into the big ideas that I had for week 6. Yeah, my big ideas for week 6 here. I'm trying to start moving away from just thinking of data as like ephemeral, always living somewhere else, and starting to bring it into a single source of truth. So we're going to start thinking about relational database systems, what it means to be relational with our tables and our data objects. We're going to be talking about creating primary foreign keys, mapping entities back to each other, etc. We're going to talk a lot about SQL, that is the main language of relational databases and structured data, your DDL and DML clauses, as well as your query clauses and aggregations that are all built into SQL. I had a good note to one of the forums about declarative languages like SQL, so definitely give that a read if you want some more details on this. How do we query cross tables using our entity relationships, multi-table reasoning? How do we bring the results back into Python and Pandas? How do we use databases as a source for ETL pipelines, but also or as a destination for ETL pipelines, but also as a source for exploratory data analytics? And then how do we clean data up? Real world data is super messy. So how do we not freak out or get too anxious about it? How do we make sure to keep everything around our metadata, columns, data types all ready to go? The goal is operational, business ready, enterprise databases, not necessarily textbook SQL. And we'll be interacting with a lot of different databases here. So some of my learning results, you should be able to design simple relational databases, load CSVs into tables, write simple queries, use aggregations, use joins, combine tables together, combine queries together, and then pull everything back into Python and Pandas as needed. So it uh, should be a good class here. In terms of content, there's a lot of media sets. Where are we? We're over here. There's a lot of media sets for week 6. Oh, also, I'm gonna back up everything onto my YouTube channel. So if you haven't looked, you probably haven't found this yet, but I'm gonna link things to my YouTube. So you'll see here that I also usually teach like data science. So you'll see some data science stuff. I'll have a playlist for data analytics, and I currently do work at a company called Databricks. So I have some Databricks workshops and things that I've also uploaded. So yeah, if I do any backup videos as well, you'll see that up here in YouTube. So definitely check out YouTube, check out my LinkedIn, follow me, connect with me as needed. Again, I want to make sure that as much resources I create for your consumption is actually used and worthwhile to your time. Let's see. I have my week 6 preview already posted. Again, if you're already familiar with SQL and databases, then feel free to skip directly to the end. 6:11, 6:13, those are going to be where we start tying databases back into Python and data analytics. There's 3 different types of labs that we'll demo here today. I call them like an IDE lab, and then like the MySQL labs, and then the notebook labs. So we'll work through all of them. Don't feel like you have to do every lab in the week. There's way too many of them. Try and open up MySQL in a new browser, just because it gets cut off otherwise, and really, really focus on tying data back into Python and Pandas. The final project of 616 is the most important activity of the week. And I'll try and post a preview video going into each week or I do like a review preview video that I try to do. So going into week 7, I'll try and do a review of week 6 and preview of week 7. So that'll be posted sometime Friday or Saturday this weekend if I get the time to do it. Cool. All right, let's take a stab at some of this. Who I am, I guess I never introduced myself. I'm Alexander Booth. I've been working in the data and technology space for almost 15 years. I've been teaching data analytics and data science both in person at universities and asynchronously through boot camps like this since 2019. I used to work in professional sports where I led a data engineering team for a Major League Baseball franchise. And now I work as a solutions architect at Databricks, where I help sports businesses and sports technology companies implement Databricks' technology for kind of big data cloud and processing, ML, AI, all that good stuff. Great relationship with IBM, IBM Cloud, and kind of IBM's products as well. So I've been teaching these style of boot camps with IBM for almost 12 months now. So it's been a fun journey. All right, let's get into some of the media sets. So let's start with some of the basic stuff that you'll see this week. Let's go into 6.3 actually. So this is going to be our first type of activity that you may see. Obviously, you're going to do the videos, do your transcripts, etc. But this is going to be the first type of activity that you'll find. I call these type of activities just like your IDE activities. It's not a notebook and it's not like an actual MySQL server. It's literally just a interactive user interface where you can like practice writing queries and stuff. So here we go. Like we want to write this query, select star from film location, submit it. Wow, we wrote a query. Good job, us. Notice this doesn't look like a notebook. It just looks like a interesting user interface. So this will be the first type of activity you'll see this week. And again, a lot of this is going to be pretty straightforward stuff. And again, if you have familiarity with SQL, it's completely fine to skip these very intro level activities. If you've never seen SQL before, then I do recommend taking the time to walk through these activities and run the queries as you go and things like that, though. So I'm not going to spend too much time on this. This is mostly just bringing in familiarity into what SQL queries actually look like. Um, Yeah, I think that's one good thing here. Let's see here. Let's do a first one. Retrieve the fun facts and filming locations of all films. What we want to do here is we want to select. This is where the declarative language comes into play. I'm declaring what I want. I want to select the locations and the fun facts from the film locations table. And here we go. Embarcadero Freeway, which is featured in the film, was damaged in an earthquake. How fun. What a fun fact. Cool. Yeah, so and you can run through a lot of these IDE notebooks in your own time. I'm going to skip ahead down to, oh yeah, this is also good to know. If you see any enrichment activities are always optional. So in this case, IBM has actually given us free access or a free trial to their IBM cloud where you can create databases on the cloud. So this will give you pretty direct practice regardless of if you're going to move to AWS, Azure, Google Cloud. The IBM cloud is really not that different from any of it. So being able to create databases on a cloud is a skill that translates across all clouds. So definitely feel free to play around with the IBM Cloud trial account if you want. And especially that'll be in week 6, I think maybe in week 8 as well. But otherwise, don't feel like you have to do the enrichment activities. They're not required. Again, the only thing that is required is the end of unit quiz. So just remember that for your own knowledge too. Cool. So let's jump ahead to the next type of activity that you'll see here. I think I like some of those. Let's start with 6-8. Or actually, I want to do relational databases. Oh, maybe we'll come back to that. I want to show you the second type of activity I run into. Yeah, let's jump to the second type of activity that you'll run into, and then we'll focus on defining databases, talk about the history a little bit, and then get into some good work. So yeah, make sure you're watching all the videos, reading the transcripts on your own time, and let's see if this is the right one I want to look at. I'll wait for the lab to load. It's always the longest part. I believe in you. You gotta give the IBM environment some encouragement sometimes. That's a good thing to bring up, though. If you do see any failures in the lab, specifically in the notebook labs, you can always run my GitHub notebooks, or if you download the notebooks from the IBM labs, you can always run them in something called Google Colab. So colab.research.google.com. You can always upload notebooks that you've downloaded, or you can even connect directly to my GitHub, whichever is easiest for you. 404. And of course, the one thing I clicked on was a broken link. Let's see if we can find one of these other ones. Oh, there we go. All right, so this one's setting up. This is going to be the second type of lab that you'll see in the media sets this week. This is going to be, I guess, like the MySQL or the RDBMS, like it's the MySQL, MyAdmin type of labs. So this is actually going to give us a user interface for writing and interacting with data directly within a database management system. All right, so pen is fully loaded here. So this is what I want to notice. Notice that the lab looks different than it did from the last one I showed you. So in this case, it's not just like a click-through lab or kind of running some of the queries, but we actually have a full user interface here on the right. This is a ripoff of a software called Visual Studio Code, which is an open source IDE. But you'll notice that if I follow some of the instructions here, we're going to be interacting with MySQL running on a database server. So MySQL require most relational databases require a computer to have them installed on. So that's what this is having us do here. It's actually installing a MySQL database on top of our in cloud environment, which is really nice of them. So, and all free for you, which is all super nice. So what we're going to do here is we're going to create our MySQL database, which is going to create this my admin user interface on top of it. And we'll wait for this to turn on. There it is. So here we go. This is what I was talking about. You can either open up this inside of the UI here or in a new tab. And I always recommend doing it in a new tab. Open up the My Admin MySQL interface in a new tab. If you open it within this little VS Code thing, it doesn't show you the whole page. It all gets cut off, which is really frustrating. Contrast that to the full lab environment here. This is what it's supposed to look like. And now we can follow along with the instructions where we need to create a new database. We call this MySQL learners. And then inside of my database, we want to create some tables. I'll download this script here. And in my lab, we should be in the table, import. We're going to import our SQL script. And then if all goes well, we should be able to run everything. Which I think it should execute automatically. Import is successfully finished. 3 queries executed. So if we refresh this, under my pet rescue, yeah, we should be able to see the columns. There we go. Uh, ID, animal, cost, quantity, rescue date. Cool. And so now if we go to a query, we should be able to write a query. Select sum of cost from pet rescue. And there we go. Our submitted cost would be $1,718. Sweet. So that's all we're doing here. Again, big ideas is that when we are using the MySQL interface and the MyAdmin interface using a new tab, this is like a really standard database management system interface. If you have familiarity with SQL Server Management Studio, SSMS, this looks a lot like SSMS in my opinion. And regardless if you go into Oracle, Postgres, whatever, they're all going to have database management interfaces that look a lot like this. So definitely get some familiarity there. Cool. I think that's all I had for the walk through the lectures for these things. I got some actual lecturing to do now. So let's do that. For the lecture itself, I'm not going to get too caught up in the weeds of some of these media sets. We're going to walk through some ideas around relational database systems. I'll give you some history of it and why this is important. And then we will jump into some of the connecting it back into Python and running a couple of those notebooks. So yeah, let's get started. All right. So first thing we want to talk about here is a quick history of relational databases and why they're important. So you should already have a framework now of the different types of media sets and labs you'll see in the week. Introduction to SQL, advanced database management systems with MySQL, and then connecting databases to Python with Pandas, which we'll do live here in the second half of the lecture. But first, I want to give you a little bit of rundown of the of relational databases and kind of the point of them, as well as a little bit of the history. So why not pull from IBM's own documentation, which I think is really good. So we'll kind of scroll through a few of these. We'll give you some of my own thoughts here. and then we'll focus on a few things. So I think it's a really interesting article. It's an article about what is an actual database and what's the importance of it, right? Typically, when we think of databases, you need to think of two types, relational and non-relational. You can also start thinking about vector databases as well, but depending on your definition, that could fall into its own other data store. At its base, a database, the whole point of a database is to provide a single source of truth for a coherent data architecture so that users and applications can access and trust the data when they need it. Databases are foundational to these data architectures. And instead of just being a single source of truth, like I said, they enforce data integrity and security standards, as well as accessibility, data access, auditability, as well. With the proper database systems in place, organizations can use high quality data for a range of applications to drive data-driven decision making, which at the end of the day is the whole point of data analytics. So for relational databases, those are going to be your classic. That's what we're going to be talking the most about this week. And here, relational databases are going to be mostly structured data sets, with rows and columns with clear relationships between them. Non-relational databases are going to be storing semi-structured or blob storage information, such as text, audio, video files. And then the newest ones, vector embeddings, vector databases, they store your vector embeddings for typically your RAG applications or many other generative AI applications. Um, a database to me is not somewhere where there is integrity questions or multiple stores of truth. So people sometimes say that like an Excel workbook or Google Sheets can be a database. I challenge that because I don't think that can fully be a single source of truth, as well as providing the data integrity rules that most people expect their systems to implement on across the database. Yeah, there you go. Microsoft Excel is not a database. Databases should be robust, centrally managed systems. All right, let's start with relational databases and relational database systems. So a quick history, databases have actually been around since the 1970s. They've been around for a long, long time. The first databases came out of IBM as well as Oracle. And it was a really great idea, great way of storing and retrieving data and records with strong controls in place around their governance. Especially being able to use simple declarative SQL statements to basically declare or name what they wanted to extract out of it and made data accessibility much more democratized across the board. To speed up processes, these databases were also optimized by indexes and reducing redundancy, right? So data can be combined without needing to duplicate data. For the longest time, about 20 years, the 1970s, 1980s, the only databases you can manage were licensed. So these were large proprietary databases from IBM, Oracle, Microsoft. Your Microsoft SQL Server kind of fits in here as well as a licensed relational database. In the 90s, the relational databases pivoted into open source. So you ended up with Postgres, MySQL. These are all open source databases, Mariah to an extent as well. And these open source databases to me helped implement the dot-com boom in the 2000s. Now that it was cheaper than ever to store data in a single source of truth, it became quicker and easier to start deploying applications that relied on databases at greater velocity. Going into the 2000s, databases moved into NoSQL, non-SQL land. NoSQL databases allowed you to store information as blob storage or even a semi-structured key value pairs. By not having a rigorous schema in place or required needed for data right, we were able to start storing data much faster with much more flexibility in terms of how it was generated. This kind of led to the first prototype data lakes, where data would just be deposited into NoSQL or storage buckets and then taken out of those entities and loaded into relational database systems when we had the manpower to engineer those pipelines. Going into the 2010s, databases moved into the cloud. So what this means is that before we had to install a database on a single computer. This meant that if we wanted to store more data, we had to vertically scale. We had to get a bigger computer. But with the advent of cloud, it allowed us to scale horizontally, linking together clusters of computers together to work together to power our databases. This led to modern data warehouses, your AWS Redshifts, your BigQueries and Snowflakes of the world, which allowed us to horizontally store and query data using many clusters of virtual machines to do the work for us. Going to the 2020s, we now have these two paradigms of your data lake, where your raw, semi-structured blob storage objects went, and your data warehouse, where your structured objects went. But we really needed a unified way to connect all of those pieces of information together, as well as make them governed, auditable inside of a data catalog, and available for AI integrations. This led to the rise of the data lakehouse and data mesh formats, where all of our data is all living together. And we use some of it for warehousing, we use some of it for modeling, some of it just as a data lake, and some of it maybe just for graph databases or something. And this really created as long as it's governed correctly, it allowed us to create a good single source of truth for all our AI models to go reference or humans to go reference to find any bit of information within our data ecosystem. And yeah, there's some more ideas around this where new SQL databases are going to be more adopting a distributed, horizontally scaling architecture, distributing data across multiple computers. We talked a little bit about NoSQL databases. Typically, NoSQL databases I see most common are going to be your document databases or key value databases. Document databases store data just as API JSON blobs. Key value databases are mostly used for caching to quickly retrieve key value pairs from a store. And then graph databases allow us to track relationships, especially across like who knows who on social and networking sites. We talked about cloud databases already. Again, every cloud will offer a database as a service. So again, getting to know it in terms of IBM is fine. And then yeah, here we go. We touched a little bit on the differences of data lakes, data warehouses, and lake houses. Data lakes allow us to store any bit of information. There's typically it's not cleaned, validated, or normalized, but it also allows us to store unstructured data, specifically text and video. Data warehouses are typically aggregated and cleaned, and are typically is what powers uh, many like applications and BI business intelligence tools. And then finally, lake houses combine the best of both worlds. It wants us to be able to store large amounts of all types of data and make it available for AI and analytical workloads downstream. All right, let's bring it back. That was a quick history of databases. Let's start looking at entity relationship diagrams. And I like to tie this back into data normalization as well. Yeah, this is a good, some good documents. So let's first touch on data normalization. I think this is the one I was looking at from DigitalOcean. Yeah, that's what I was looking at. So with database normalization, this is basically how database diagrams are typically formed. So with a database, we typically want to define relationships to remove redundancy and optimize for data memory, right? And database memory, especially when these are only running on a single computer. We need to make sure that we're maximizing the data storage as much as we can. So quick thought exercise. It's always cheaper to store numbers and integers versus to store long texts of strings or objects. It's just less bits, less bytes of memory to store. So if I have a product description, I should try and only store that once and then look it up or connect to it using joins across IDs. And hopefully those are integer-based IDs to minimize that data replication. So we'll walk through the first three normal forms, which are typically very classic for database design principles. So your first normal form is we need to flatten our data out. Data should be flat in rows and columns. So, and then in our second normal form, we're adding in primary keys. And our third normal form, we're adding in all of our foreign keys. Basically, it's how it works. So here is a table that is not normalized and it's not flat. It's not even in our first normal form. It's not flat because we can see that customers are buying multiple products. We have multiple pieces of information in a cell. It is not flat, so we need to flatten it out into a normalized table. To flatten it out, we can just do this, where we now have our customer ID, customer name, and then the product that they bought. Now, this leads us to our second normal form, which is, wait a second, we have repetitive strings here, and we always want to minimize repetitive strings. So looking at the customer name, right? John Doe is repeated, Alice Brown is repeated. We don't need that, right? We can just join to the customer ID to know who bought a specific product. So if we go down to our second normal form here, what we're going to be doing is we're going to be breaking out our customers into a separate table. So we're going to have two tables here. We're going to have our order table where we say that order 201, customer 101 bought a laptop. And then we can go look up in our customers table that customer 101 is John Doe. So notice the only thing duplicated is now the integer. And remember, it's a lot cheaper to duplicate and store integers than it is to duplicate and store strings. So we have eliminated redundancy of customer details and we've simplified data maintenance. We can add new columns specifically maybe about John Doe's birthday or something. And we only have to add it once to the customer table. We don't have to add that piece of information anywhere else in our data architecture. Similar thing with third normal form here. We can start adding in more foreign keys. So both product and supplier should probably be their own tables. So we can have a product table that includes the product name and the supplier ID, a supplier table that has the supplier ID and the supplier name. And now my order table looks kind of lame. This is what my table turned into. It's a table of IDs, and that's all it is. Maybe I would also add like the order date here as well. That could probably be a useful column. But here we have, if I want the customer information, I have to join to it. I have a relationship. I have to join on customer ID. If I want the product, I have to join to the product table. I have a relationship on product ID. Similar thing, if I want the supplier, I have to join on the supplier ID, right? All the way to those products too. So again, we've gone ahead and we've added in those primary keys, foreign keys, and reduced that duplication in our objects. So let's bring it back to what a data model looks like. It looks something like this. Here we see we have our sales, product ID, we have to join to product, and we get the product description. Store, we can join that to the store table, get the store region, etc. Maybe date, we can get better descriptions about the dates of the items sold from the date table. And we end up with all these dimensions and facts tables. That's going to be something that you're going to hear a lot. So a fact table is going to be your main big table with a lot of rows. Your dimensions, a lot fewer rows, typically what's joined to the larger, bigger tables. This is known as a data model or data modeling. So you don't need to go too in depth about data models, but it's pretty interesting to know. Definitely read up more of it in your own time. What this also means, though, is that with databases, you have strict schemas that you have to adhere to. Because if there's any difference, then you're not going to be able to insert the row or do those joins. So the strong controls in terms of data quality and data expectations are kind of already built into a entity relationship diagram like this, which is pretty neat. Finally, we already touched on database management systems. We already seen one, specifically MySQL. That's what I showed you earlier, the MyAdmin, PHP MyAdmin thing. That is a database management system for MySQL. So again, interfacing with that tracks with pgadmin for Postgres, SSMS for SQL Server, Oracle, IBM, whatever your database is, they're all going to have some kind of management system on top of it. And why they all use SQL, one thing to note is that these different types of databases have different flavors of SQL. So SQL Server uses something called T-SQL or Transact SQL, which is a little bit different than Postgres, a little bit different than MySQL, a little bit different than Snowflake or Databricks or whatever. But again, mostly SQL is fine. It's pretty common across the board. But just like with anything else, memorize logic, don't memorize syntax. Finally, we'll end with why databases matter and how they're used in modern AI platforms. So again, biggest ones are supporting data usability, data integrity, and data security, right? So data usability. We want to democratize access to data. 68% of enterprise data is never analyzed. Crazy, right? So your job as data analysts coming into here, you need to be that person, that unicorn, to be able to go off, request data, request access to data, and start analyzing it to your heart's content. If we are able to store and curate data effectively in a centralized single source of truth, we should be able to make it easier for people to access it to bring into their analytical workflows. And again, what's the point? What's the point of data analysis? Drive better decision making, right? Fuel business intelligence, drive data-driven decisions. Sure, we could do that with an Excel workbook, I hear you say. Sure, whatever, you could, but gross. The other good use cases for databases include data integrity and data security. So data integrity specifically, they conform to specific schemas and expectations. With spreadsheets, you can have errors, human issues, inaccuracies, right? You're losing kind of that integrity, that trust in the underlying data. But with databases, they allow you to have clean data, formatting rules, and also allow you to track lineage, how data moves across your data architecture and your data ecosystem. Databases remove the needs to have multiple copies that can fall unsynchronized. Instead, everyone works off of the same single source of truth. Hopefully, I'm hitting over the head with this. Single source of truth, resiliency, integrity, and trust. Finally, data security. There's a lot of regulations out there like HIPAA and GDPR and COPPA and all your other favorite regulations. Oh my God, regulations. So because of this, being able to secure data securely can avoid data breaches, can avoid unnecessary lawsuits, and can make sure that you're complying with your laws and regulations. We can also integrate role-based access controls as well as attribute-based access controls, your RBAC and your ABAC, to help have that full governance and auditability on who is accessing what data. Finally, connecting data to AI. This is one of my favorite topics right now. I think it's always easier to bring AI to your data than to have all your data be all siloed and disparate and try to grant different access roles to different AI tools. By having AI know where to go to find your information makes it a much more powerful tool to drive business decisions, right? To support your own analytics. You can reduce hallucinations by telling it to go to specific data stores to look up information. And then caching key value databases can help with that as well. Some things to consider when choosing a database. Usually you're going to be dealing with relational databases. So it's whether or not you want to go open source or licensed. Figure out the purpose of your database. If you're going to do a vector store, don't use Postgres, or you could, but like you probably want to use a vector database like Pinecone or something instead. Try and optimize for performance, price, and scalability. As the data grows, as the database grows, are you going to be able to keep up with the price? Will the database system itself be able to scale out as well to meet your needs? It's a lot of good things to consider as we go there. All right, let's jump into the notebooks and then we'll do the quiz and get out of here. So we're just going to jump into the only notebook that I really care about this week, which is going to be 616, being able to write queries against the Chicago data sets. So what we're going to do in this notebook, we're going to do a few things here. We're going to read data from multiple locations. We're going to write that data to a database, and then we're going to write a handful of queries. And then at the end, we're going to execute those queries and bring the results back into a data frame, which we can then use for visualization or analytics with pandas. All right, so we're going to make sure we're connected to our kernel here. Everything looks good. These are the three CSVs we're going to be bringing in. It's all real data coming from the City of Chicago public safety initiatives. So we're looking at socioeconomic indicators, school data, and crime data. All right, so I'm going to go ahead and clear all of my outputs. And let's go ahead and start running some of these cells. So the first thing we're going to do is we're just going to like make sure we have all of our libraries and settings and everything needed. Then we're going to go into downloading our data or reading them into a data frame and then writing them out to a database. So this is a very like rudimentary extract, transform, load, extract, transform, load data into our database. So again, the purpose of this week is not ETL, but more on the opposite side. How do we take data out of our database for analytical purposes? We're going to make sure that we're able to run SQL in our Jupyter Notebook. That's what these magic commands allow us to do to write other languages such as SQL and what is traditionally just a Python-based Jupyter Notebook. And now let's go ahead and create our tables. So 1, 2, 3. We have three tables here, over 1,000 rows, 566 in this one, 533 and 78 in this one. Next, we're going to connect to our database, and now we can start writing some queries. Let's get after it. Query number one, find the total number of crimes recorded in the crime data. First thing I'm going to do is I'm going to select star limit 1. This brings back the first row, which allows me to take a look at the columns so I know how I can write the real query. What we want to do is we want to count the IDs or count the rows. So I'm just going to count ID here. We come back with 533. Of course, you could just count all rows, count star. In this case, that also returns the same result. Typically, counting by an ID is going to be faster though, as again, we're ignoring all the random text stuff and just looking at the IDs, which are typically integers here. For number two, we're going to the census data, and we want to look for all community areas with a per capita less than 11,000. So looking at my columns here, here's my community areas, and it looks like we do have a column for per capita income. So this is going to introduce the where clause, select these columns from my table where my row is less than 11,000, order by that per capita income ascending. And here we go. We get Riverdale with a per capita income of 8,000 is the lowest one. And we only have four neighborhoods below 11,000 in terms of per capita income. So that's also pretty interesting. Next up, look for crimes involving minors. This introduces our string filtering or our string regular expressions. In our case here, we're going to be looking for all rows where the description contains the word minor. That's what we're looking at here. So I want select these columns from the crime database, from the crime table, where description contains the word minor. And we end up with two, selling liquor to a minor and illegal consumption by a minor. So we have two rows where the crime description contained the word minor. If you do child here, I don't think anything comes back. Oh, there you go. Uh, I guess children are not considered minors for the purpose of this analysis. So child, yeah, we have child abductions and things, so we don't want to do that. So let's stick with minor, and we just have selling liquor to minors. Next up, list all kidnapping crimes involving a child. Same type of thing here. We have these columns from this table, and the most important part is the where clause, where my primary type is like or contains the substring kidnap. And so we got two clauses, and the description contains the substring child. So we only have one result here. We have a kidnapping that was of a child abduction in 2007. Next, we want to look for all the unique crimes that were recorded at a school. A couple different ways to take this one. My first attempt here, I just selected these columns from the crime table where the location was at a school. Technically, this doesn't bring any repetitions back, but it's because it's uniquely identified by like the case number. If we only wanted to bring back the distinct, unique descriptions and primary type, we can do that down here. Select the unique primary types from the Chicago crime data set, where the location description contains the word school. So if we run that, we can see that the unique crimes at a school are assault, battery, criminal, narcotics, and public peace violations, which is interesting, and drugs. Hopefully there's sound. Let me recheck my sound here. Check one, check two. All right, so we're still recording with sound. Let's go. Cool. All right, almost done here. List the types of schools with their safety scores. So now we're going into the school table for the first time. Let's see what it looks like. So here's all of our columns, a lot of good stuff. Notice it's got a community area, which allows us to do a join if we need to the community table. So here we're going to be selecting the type of school, and we're going to be averaging the safety score, and we're going to be aggregating, grouping by the type of school. So it looks like high school has the average safety score. Just for grins here, let's also bring back the count of school ID. As number of schools. So now we got the number of schools. So we had 93 high schools, 400 elementary schools, only 11 middle schools. So maybe this 48 is due to a small sample size as well. Number seven, the list of 5 community areas with the highest percent of households below the poverty line. Again, same deal. Notice we're going to be grouping by the area name and number from the census data. And we end up with the same ones as before, but we can see here that 56% of households in Riverdale are below the poverty line. You may notice why I'm doing a max here. This is a max of 1, so it's just going to be the same number. I could do average if I wanted to, but because we're aggregating by doing a group by, even if there's only one row per group, we still have to aggregate it somehow. So that's just like a silly little SQL nuance. If you want to do it without any of this group by, you don't have to use a group by here because we do only have one row. We can just select the area name number and percent of households below the poverty line. So this is the same query just without the extra group by aggregation. And as an example of how to read this back into pandas, we're just going to use the pandas function read SQL query, same exact query, save it off as a string in Python, execute it as Python, and we end up with a pandas data frame brought back that we can then start analyzing. Next, a couple more here. Which community area is most crime prone? Notice we're going to be doing a join here. We're going to be joining crime data to the census data. We're going to be aggregating by the community areas, and we're going to be counting the number of crimes. So I want to have the number of crimes greater than 20. And so here we go. We have three neighborhoods that had more than 20 recorded crimes in the crime data table. Number nine, we're going to be using a subquery. That's what this guy is. We're going to be grabbing the max hardship index from the census data, and then we're going to use that as a filter. So we're selecting the community area from census data where the hardship index is equal to this max. And we end up with, again, Riverdale showing up here. And then finally, in this case, I wanted to use a subquery to find the community area name with the most crimes. This is a different, a weird one. It's the same question as number 8 here, where the answer is Austin. So I just copied that query down, and again, it's Austin. But I'll leave it as an exercise for the reader if you want to refactor this to use subqueries instead. So yeah, nothing too crazy. I want to make sure that we have everything good to go here. So yeah, if you have time, definitely run through this notebook. I think the other notebooks in week 6 are definitely worthwhile. The more impactful ones are going to be the Python-based notebooks. So 611, 613. And then if you need the extra time and practice, go back and do the intro to SQL exercises. Again, if you run into trouble with anything, you can always follow up in my GitHub repository. For example, I already ran through this module file or this module notebook on my own computer on my own time, just to make sure that everything worked before lecture. So you can always go back and check my notebooks if you want help while you're running these notebooks on your own time. Yeah, hopefully you don't get too stuck if you get have some barriers. Oh yeah, that's a great plot. I love this joint plot that we created in 611. Look how cool this looks. You got the histogram and the correlations. Very cool. Again, all coming from executing SQL queries and saving that off and integrating it with Python. So definitely a fun week. Definitely take the time to spend on 611, 613, and then pull it all together in a 616. I think we'll close it out. We'll close it out with a quiz. Let me actually download these so I have them. All right, let's close this out with the week 6 quiz. I'm gonna go down to the module 6 quiz. Again, the quiz are the only things that are graded for each week, so make sure to do them. Let's see. 12 questions. All right, let's see how quickly we can fly through these. What does each of these queries do? Update instructor. So this is DDL or data manipulation, DML. So we're going to be changing the last name of all instructors named Smith to Brewster. So it's just A here. Yeah, we're going to find where instructors are Smith and change them to Brewster. What would occur if you execute a delete on a table without a where clause? It'll delete the whole table, but leave the table intact. It'll remove all entries, but still keep the table present. To delete the table, it's drop table. What's the expected result? Select count of unique first names from instructors. We're going to get the count of unique entries. The number of unique first name entries, I think is what we want. What of the following is correct? Data can be added. That is not correct. Data can be modified. A database is a logically coherent collection of data. That is true. We've shown that we can use Python as well, besides SQL to query data. So C. Create table is a data definition language or data definition statement. Removing a table and all of its data is drop table. In SQL, which of the following will resort a result set in descending order? Select star order by ID descending. I think both A and D work, but we're gonna go with A. Select star from table name order by ID descending. That'll definitely work. Yeah, I'm not sure. I don't think it'd be D here. It could be D, I guess. Maybe it's D because we're only selecting the ID and then sorting on ID. I don't know. I'm gonna go with D, I guess. What is the role of the having clause? It filters a group by, restricts the result set after a group by. What's the choice best describes the function of the following SQL query? Retrieves all columns of the top five rows, sorted. It's sorted alphabetically because so it'd be B. Retrieves the columns of the top five rows sorted alphabetically based on employee name. Yeah, this is not C because does retrieve all columns, and it's not D because we have a limit five. What is the use of cell magic? Technically, you can code in using a programming language other than Python, and then also A. You can use timings with magic commands. So I'm gonna go with A and B. Although if you go B and D, I think that's fine as well. But I think the answer one's A and B. What does this code do? It reads in a CSV and writes it to a database. The CSV file is saved to the HR database. I guess it could also be D. The CSV is read and converted into a SQL table employees under the HR database. I guess it could be D as well. B and D are both all right. I think D is the better answer here. Last one, which the following statements would use to perform a statistical analysis? We'll be doing df.describe, and we'll be doing a lot of this in week 7. So that's a preview question for next week. Let's make sure this worked. Submit all and finish. Oh, 11 out of 12. We missed one. Let's see which one we missed. Oh, we missed 7. Oh, so it was A. Okay, so whatever. I was close. This would be select star from table, order by ID descending would be the correct answer there. Although D technically also does this. Whatever. It's fine. All right, we'll wrap. Again, expect a lecture review post in the forums coming up. Make sure to spend your time working through the SQL labs and specifically the Python SQL labs. If you need help on that, reference my GitHub. And again, most important parts of the week are the Jupyter Notebook labs. How do we connect SQL into data science and data analytics workflows? For the other labs, try and play around with them, but don't worry too much about it. And don't get stuck on syntax. Focus on the big ideas around what is a relational database, what's the history of databases, what does a good data architecture look like. Don't worry about finishing everything 100%. Focus on the Jupyter Notebook projects. Reach out in the forums or onto my GitHubs if you need me. And I think we're good. So remember, our next live session will be next Tuesday at the normal 1 o'clock Eastern time, I guess. So I'll see you all at 1 o'clock Eastern next Tuesday for our week 7 lecture. We have 4 more lectures after this one, and I'll also go back record and upload live lectures for weeks 4 and 5, maybe weeks 3 if I get around to it. All right. Thanks, everybody. Hope this was helpful. Please reach out in the forums if you need help. Otherwise, I'll see you all next week, and hopefully there'll be a couple of you on live. Otherwise, feel free to watch these either on YouTube or on Zoom, and I will see you all in the next one. Thanks for the time. Thanks for the attention. Have fun working with SQL this week and get excited for exploratory data analysis and regression analytics and predictive modeling in week 7. See you all then. Take care. Have a great week. Have a great weekend. And I will see you on the other side. Thanks, everybody. Bye.